question. So
Yeah.
you said that you can reduce like 30 dimensions to 3 dimensions,
Yeah.
and so these are the variables that are fed into
Yeah.
the model.
Yeah.
But then this might give a better model, but then how can we explain the effect of each of those individual 30 variables on these?
Yeah, that's a wonderful question. That's a very practitioner's perspective question. So, like, what usually when you see the data, for that, I'm sorry, I don't have real data, I should have done it. Then it starts becoming very clear. So suppose I calculated that time spent on internet, time like GPS, RS, and say time spent on Wi-Fi. And usually they're always correlated. And shopping done, chatting done, okay? Instead of a person who just makes calls.
Yes.
So all these things will start clubbing towards one axis. And you'll get an idea, okay, this is what is happening. Basically how much the person is addicted to internet. How much the person is, now these are the calls factor, like, you know, his banking transactions are, suppose you have that data also, your banking and telecom company combined, Paytm and something like that. This fellow is a businessman kind of something, and these two axes always come together. So then you start calling them something else. That mathematics cannot do, that a practitioner like you can do. This you call something like that, and you try to explain the people, okay, these things are related. Something very counterintuitive thing comes. But once it comes out, then you understand, oh, it's like this, why could I never think that? Data throws up such things. So, that is. Say how much you value brand, how much you value money, how much you value other stuff.
Okay, but what variables combine into one variable that the model can explain?
Those principal, those loadings, those
okay,
principal,
yeah.
like once you decided x1, that lambda 1, lambda 2, lambda 3, so that matrix, so okay, this, you know, the first column that I'm getting with maximum variance, so this one is high, this one is 0, this one is high, so the first axis, the 7th value and the 30th value and the 25th value, these two have very high loadings, weightage, principal loadings are but the weightage. These are with this, the new axis, the first biggest which I got with maximum variance, is loading with, you know, these columns and little bit with other columns. So, okay, these are things which are related. Clear? One thing that I have not mentioned is standardization of the data. If I take one column in terms of R and in one term or instead of taking in terms of second, then you know the spread will become, its impact will become very high. So for each of these columns, we need to subtract it with mean and divide it by standard deviation, so that the impact of the the range of the variable should not impact your analysis.
And what about if there are any categorical variables?
Yeah, for category variables also.
So those will be converted to factors, and then
You just standardize it
and
and
then standardize the factors.
This is mainly used for feature selection. Main is, let me see if I missed out anything. All this I have. It removes multiclinearity, that problem is taken care of. Removes all redundant features. Decreases the number of dimensions. Started with a lot of usage in image recognition. We have those pixels of data, 365, and then what number is that, 7 or 9 or those kind of thing. But move to marketing and every dimension of business very fast. Just by rotating we are not losing the information, but when we ignore these axes, at that point of time we are losing some information, and how much we are okay to lose that information. Okay, I think I have covered. And it's a global algorithm. It's not taking a set of data and working on it. It's working on the entire feature space. Fine. Any other question? One last thing I'll do before I close is something called the curse of dimensionality. Like how bad is dimensionality? Curse of dimensionality is very, very difficult thing to get an idea. So suppose I have a square, a unit by unit square, okay, and I take a random point, I throw a dart and hit somewhere. I just mark that point and take that dart out. I throw a dart again, and assuming it hits inside, not like how Pranav says it goes everywhere. So what will be the expected distance between those 2 points? Any idea how to find that out? The expected distance between those 2 points. Okay.
This is making a rough guess. Mean of the distance.
Yeah, make any guess, yeah. Mean of the
Mean
distance.
of the distance of every point to every other point.
Exactly, absolutely. Absolutely, wonderful answer. But then, how do we get those at each point? So first, let's say this point is x1 comma y1 and this point is x2 comma y2. So the distance formula is that simple, x1 minus x2 square plus y1 minus y2 square under root. Clear? But then, say, forget about everything. What will be? How will we get x1? What will x1 vary from to what? This is a 1 unit, this is a 1 unit.
0 to 1.
0 to 1. x1 varies from 0 to 1. x2 varies from same 0 to 1. y1 varies from 0 to 1. y2 varies from 0 to 1. So what distribution is this? Is it like normal distribution that the chances of hitting center is more or something? I mean, randomly is selected, not someone is trying to throw a dot. If someone is trying to throw a dart, then center would be a higher probability. So this is a uniform distribution. Okay, we have not done this, but if I take two variables x1 and x2 and take their sum, both are uniform distribution, then the sum will have something called a triangular distribution. So we won't be going in all this. So basically then we can calculate the probability density function, we can integrate it over all the values of x1, x2, y1, y2, or I take it r and theta and make my life easier, and then the probability of all these elements. And then what you get, this distance is, say, I think, how much was it? 0.52. We solved it yesterday. It's in a 1 unit square. You know, in say, if I have, this is in 2 dimension, right? If I make it in 3 dimension, then that increases to 0.6 something. Suppose I increase to 100,000 dimension. Any guess what the distance between 2 points would be? In a unit by unit along our dimension cube. Every side is not more than a unit width. Can it be greater than 1? In a multi-dimensional space, there's a cube, like x, y, z, w, all those dimensions, the length is 1. Here it's 2 1 unit, in 3 dimensions this is 1 unit. In 100,000 dimensions, can it be greater than 1? Yeah, since I'm asking it, it's the distance between those 2 points is 100. So however much point you have, as the dimension increases, the things are spread out. You know, it's maybe the same small box, but it's very difficult to get an idea. The density becomes very less, and doing any analysis on that density is like in a galaxy or just alone kind of thing. So that's why the curse of dimensionality in any problem solving is a huge thing, and PCA is one such method to reduce the dimensionality.